Namaskar my dear friends. Let's talk about transistor as switch circuit in LTSpice. So as we have been seeing LTSpice circuit simulation, we can simulate transistors as a switch. So this is a very easy transistor circuit and we will come to know that whenever my bias voltage is 0, then transistor is not working, hence the output voltage is 0. Whenever my input voltage is high, my output voltage will be this transistor will be working, so it will become 0. So this is how it will be working. Basically you can see, let's open LTSpice and we'll try to understand this particular circuit how it works. Basic things is I'll just tell you quickly. Whenever my bias voltage is high, this starts working, and this is how, this is my, let us say, V out. So V out will go low, okay, and whenever this goes low, then what will happen? My V out will, this will be off, so my V out will be high, that is whatever the voltage V12 V2, that is 12 volt, which will be there. Okay, so good. Let's open LTSpice and just try to analyze this. So I'll just remove all these circuits available in the diagram. Okay, so this is my window of the LTSpice. We can open new schematic by clicking this plus symbol, or otherwise file, new schematic. Okay, now let us quickly put transistor and voltage and everything. So we'll put one voltage symbol, one resistor here as a output resistor. This will be my collector resistor, and let us say this is my resistor at base. Okay, coming back to, we have to put one transistor, so we can select the part and we'll put NPN. So this is my NPN transistor. We have to search in the part box NPN, so this is going to be my transistor. Okay, so we can connect at this place. Now if you want, we can always move by press M for move, so it will move. Okay, so you can select that and you can move it. Otherwise you can move by this one. Let's say you can move this here and there. Okay, this is how you can move. Okay, that's not a problem. Let us put one more voltage symbol so that we can bias the collector of the transistor, and we have to put ground for each one of them, so we'll put ground for each one of them. Okay, so this circuit is complete now. Now we'll quickly wire it up. So wiring is like this. Okay, so if you wire this up, then you will see a complete circuit with our NPN transistor. And what we can do is, we can take this output at the collector pin. Okay, so we can do this one. Let's say one more ground will connect at this emitter pin. So this is my emitter, this is my bias base, and this is my collector of the transistor. Now what we'll do is we'll quickly take up some values for all these parts. So what we'll do is, we'll try to give here either what you can do is, directly you can bias this with a current, let's say 30 microampere current or 10 microampere current, something like that. Otherwise, since I have given a resistor, then I can have this resistor to be a little bit higher value, let's say 100 kilo ohm. And voltage source, I'll just keep a pulse voltage with, let's say, 3.3 volt or something like that. Okay, anyway we don't need more than 0.65 volt, because the diode drop across the base and emitter junction will be 0.7. so in that case you can keep that much, but anyway I'll just keep it 3.3 volt. Okay, and because anyway it has a better functionality. And time delay, I'll just keep 0, t rise 1 microsecond, t off 1 microsecond, t on, let us say 10 millisecond, I'll just keep it on. 20 millisecond will be total time period. It means 10 millisecond on, 10 millisecond off. So this is my pulse voltage that is there. Remember one thing, if you want to use a bit higher value of a pulse signal, then you can use a voltage divider here, and you can reduce the resistances also. This much is not needed. Okay, so if you want, you can reduce this to 10k as well, not a problem. Okay, coming back to this particular resistor, so we'll just keep, let us say, 4.7k, and this resistor is output resistor, let us say we will keep 10k. Okay, and this collector voltage will just keep, let's say, 12 volt. So now my circuit is ready. We'll run it. So keep saving data up to, let's say, 100 millisecond, because we have 20 millisecond period, and start saving data from 0. Okay, so this is our input signal. You can see we have the input signal from 0 to 3.3, and we have output signal. How it should look like? Whenever my input signal is high, my output will be 0, output will be low, and whenever my input signal is low, my transistor is not working, it means output will be 12 volt. So this is how it will work. So this is my output. What I'll do is, before clicking on that node, I'll just name the nodes. Okay, so let's say V out I will node. So this is my V out. Sorry, this will I'll keep V out, and this is my V out, and delete some of the parts. This is named as V out, so I'll put it as V in. Okay, good. So this is my input voltage, this is my output voltage, this is at bias and all. So if we rerun it, we can just put, this is my input voltage V in, so we can see the name of the net and say name of the signal, and this is my V output. So the blue color, you can see what is happening is, whenever my green color is high, my output is low, and whenever my green is low, since the transistor is not working, my output is high because it is 12 volts. So you can see it is coming 12 volt. There is a drop in here, so we'll see why that drop is happening. Yes, it is very easy. You can see here very easily that there are two resistors in voltage division. You can see R2 and R1. So it is giving you around 8 volt. Why? Because 10 kilo ohm is there and 4.7 kilo ohm, around 5 kilo ohm is there. So twice of this voltage will be available here. That's the reason it is 8 volt. Okay. If you want to keep little bit higher voltage at the output, then what you can do, you can reduce this resistor value to, let's say, 1 kilo ohm. Okay, so what will happen, this will become almost 11 volt or something. So let's rerun it. So you can see it is becoming 11 volt almost. Okay, if you still want to increase, you can increase this particular value, let us say 20k, then it will become almost 12 volt. So you can see closer to 12 volt it is reaching. So it's up to you, like how much voltage you want to keep at the output voltage at C node, that is collector node. So this is how a transistor circuit is simulated. So the transistor as a switch, we can see we need to have this particular understanding, and we can apply this. What we can do is, if you know the transistor characteristics and if you know everything, then you can put a current source also here, and that's how you can place this. Let us say we always want to make it on, then what we can do, we can simply right click it and put a voltage source of, let us say, 3 volt, and it will become 3 volt source, and this will be always on. So you can see my voltage at this input terminal is 3 volt, my voltage at output terminal will be what, 0, because it is always on. And whenever you want to make it off, so for that what you have to do, you have to go and put a pulse source, and pulse source accordingly you have to design very quickly. Let us say I am going to design even 1.65 volt is you are going to give, that is more than enough. Okay, 1 microsecond, 1 microsecond, let's say on time is, let's say, 1 millisecond. We can make it little faster, and let's say this is 2 millisecond, or let's say this is 5 milliseconds. So 1 millisecond on and 4 millisecond off. So this is how we can design. So yes, you can see this is my input signal, which is going to be just 1 millisecond on and 4 millisecond off. Okay, with 1.65 volt, and this is my output signal. So whenever the input will be on, the output will be 0. So this is how you can see the output is becoming almost 0, towards 0. So why it is not happening, that we'll see later, but the main understanding is like this, that we have to understand whenever this is high, this should be low, and whenever this is low, this should be high. But in the beginning I told you the circuit, that was the best circuit. You can keep this one as 4.7, and you can keep this one as, let us say, 10 kilo ohm, and you can keep this voltage source little bit higher, let's say 3 volt or something, and then if you run it, you are going to get how much. See, it is coming around 11.11, but the thing is, you are getting almost this kind of circuit. So this is actually wrong. This should not come like this. So what wrong thing we did is, yes, we have run this particular circuit little faster, I think. So let's make it little bit smaller. Okay, this was 4.7 ohm. Okay, so I'll just make it 4.7 kilo ohm. Okay, then yes, now it is very correct. You can see the thing that the mistake what I made is, here you can see this is my input voltage, which is 0 to 3 volt, and output voltage is how much? 0. So whenever my input is high, my output is becoming low, and whenever my output is input is low, my output is becoming high, because that time my transistor is not working. So this is how you make some mistakes sometimes, and like you struggle for like what is the mistake that is done. So this is how you can always solve it. Okay, and you can see it is not reaching very high because there is a voltage division between R2 and R1, as I already explained you. If you want, you can increase these values much higher so that it can reach to the very closer value of high. So thank you so much guys, hope you have enjoyed this particular circuit with a transistor as switch. We'll see more and more circuits regarding this like electronic circuit design with LTSpice simulations. So thank you so much.